So yesterday we learned 3 new theorems about how to set up a proportion to solve for an unknown length, the side splitter and the triangle bisector theorem. So let's go ahead. You want to pause the video and work these problems out. So basically when you look at this, I see that 9 and 27 correspond to each other. And then I see that 11, this is what I'm looking for. Sorry, not 11. 11 and 6 and 18 are going to correspond to each other. 11 and 6 are extra information that I don't care about at this time. All right, so I'm going to set up a proportion. I'm going to do 9 over 27 equals 11 over x. This is what I'm looking for. And when you cross multiply, you should get x equals 33. Here, this was the second theorem we looked at. This is what we're looking for, and I don't know this side here, but I can easily get it by taking 36 minus 16. So I know that this side here is 20. This is 20. So now I set up my corresponding sides. I don't know this side, and I know this side, so that's going to be my extra information that I don't need. So I'm going to do x over 20 equals, and since I started with x, I have to start with 63 over 36. And then when you cross multiply and divide, you can figure out what x is. Apparently I didn't work it out last night. All right, the next one, this is a angle bisector theorem. And if you kind of look, you kind of have your numbers set up for you. 10 over 5 equals 8 over x. So 10 over 5 equals 8 over x. And when you cross multiply and divide, you should get x equals 4. If you're struggling this, you need to review the video from lesson 27. Okay? So today we're going to look at line segments, distance, and midpoint. And all this should ring a bell because if you look on the sideboard, you should see the distance formula is there and the midpoint formula. So we're going to kind of put it together so that we can partition a line segment. And so what does it mean to partition a line segment? You should be able to answer that question, and you should be able to answer the question, how do you find the point on a directed line segment that partitions the line segment into a given ratio? So one thing we have to understand is that we are going to be looking at slope. What I want you to notice is you're going to be drawing pictures today. And what I want you to notice in each of these pictures is that the number that is more negative or smaller is always going to be on the left, if you think of a number line, and the number that is larger is going to be on the right. So if you're looking all these numbers, -2 is obviously bigger than 1, -2 is smaller than 2, I'm sorry, and -2 is smaller than 1, so therefore it's going to come first. That's going to be important when you draw your pictures, because sometimes they'll want to trick you. But please note too that if a line's going up, it has a positive slope, down is a negative slope, 0 and undefined. So that's just a quick review. What we're going to be using more formally today is the slope formula. So remember, the slope formula is y2 minus y1 over x2 minus x1. Okay. And we'll be using that today. Second thing you have to remember is what is a ratio. So a ratio is a comparison of 2 quantities, and it can be expressed using a colon or as a fraction, or one that's not up here is the word 2, so you can also say a to b. Now, what you want to notice is that sometimes a ratio is a part to part, and sometimes it's a part to whole. Today, we're going to express all of our ratios as a part to whole comparison, because that's how we're going to determine how to partition a line segment. All right, so in class today, we are actually given a Twizzlers. Obviously, you don't have one. So what we want to do is we're going to be trying to discover a point P. And you want to kind of figure out where on this Twizzlers you're going to put point P that divides the Twizzler into a ratio of 3 to 1. So go ahead and pause the video and work through this to see if you can figure it out. So when I worked this problem out, what I did was I first noticed that this is about the halfway point, and I noted that we have to divide, even though the ratio is 3 to 1, we're actually going to have to divide it into 4 sections. Okay? And then what I noticed is that this side has 1, 2, 3 parts, and this side has only 1 part. So point P is is going to be somewhere right here. So I have 3 points to the left side and 1 point to the right to give me that 3-to-1 ratio. Okay? So I would expect point P to be closer to B because it's separated from A by 3 points, or 3 parts or segments, and it's separated by B by only 1. Okay? And so again, I think I did a good job of justifying why I put point P here. There are 3 segments to the left and 1 to the right. Now, let's see if we can get a little tricky with this. If I know that A is at 3, 4, and B is at 6, 10, and again, notice A is the smaller number, so it was on the left. Where is point B going to be? All right, or where is point P going to be? Excuse me. Well, halfway we could figure out, right? We could figure out the halfway point. So this, I want you to put this on hold for 1 second. If you can't figure this out on your own, just hold on for 1 second because I'm about to show you the steps that will make it pretty easy for you to figure out the coordinates of point P. Right. And then what about the slope of AP compared to AB? Well, the slope, it doesn't matter if you're finding the slope from this distance or the whole distance of a line. Anywhere on the same line is going to have the same slope. So whatever the slope is from A to B, it will be the same slope for any point on that line. So having said that, let's go ahead and see if we can figure this out. So here we've got a more accurate drawing of point A and point B with the slope kind of indicated. So let's go ahead and take some notes. It says find the coordinates of point P. So this is very similar to what we just did. So the first thing we want to do is convert our ratio into a part to whole ratio, right? So it's 3-to-1. So it's going to be 3 to 3 plus 1. So my part to whole ratio is 3 to 4, which is why we knew to set it up that way. And to convert that to a percent, that's 0.75 or 75%. Okay? So it depends. If you like working with a decimal, you can work with a decimal or a fraction. It doesn't matter. But that's step 1. We're done. Okay? Step 2, it says find the slope of the segment. So for step 2, I'm going to find the change in y. This symbol, this delta symbol, that means quote-unquote change in. And then we're going to do change in x. Okay, so my change in y, I just look at my coordinate points. I got 10 minus 4. And my x change is 6 minus 3. Remember, if I start with 10 as my first point, I have to start with 6 as my first point. All right, so 10 minus 4 is 6. 6 minus 3 is 3. And so my slope is actually 2. And it will be 2 for the whole line. All right. But the numbers that I'm really interested in are the 6 and the 3. Okay, the third step is you're going to add the percent of vertical and horizontal change to the first point. In this case, our first point, the point that is furthest to the left, is 3, 4. Okay? So what was my change in y? Well, my change in y was 6, and I'm going to multiply it by 3/4. And 6 times 3/4 is 18/4. And if you like decimals, it is 4.5. Okay? Now my change in x up here was 3. So I'm going to multiply 3 by 3/4. And that equals 9/4. And if you like decimals, which I personally do, that is 2.25. Now, the next is to write the new coordinates. Well, you got to take the original coordinate, which is the one furthest to the left. So I'm going to take the coordinate A, which is at 3, 4. Okay? This is my x coordinate. This is my y coordinate. And I'm actually going to add 2.25 to it, and I'm going to add 4.5 to y. And that will give me my new coordinate, P. So P is at 3 plus 2.25 is 5.25. comma, 8.5. So my coordinate P right here is at 5.25, comma, 8.5. If you figured that out all by yourself, you're pretty amazing. So really you're just doing this in 4 steps. All right? Step 1, part to whole ratio. Step 2, and so on and so forth. Okay. So let's move forward. Let's say we have a 32-foot long piece of rope, and it's 32 feet long. And it's dividing in a ratio of 3 to 5. Okay, that's part to part. So part to whole would be 3 over 3 plus 5, which is 3 over 8. So I'm basically dividing this into 8 pieces. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 8 pieces, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so, and I want this point to be at 3/8. So 1, 2, right here is where I'm going to cut it. And I need to know what number goes there. All I have to do is take 32 times 3 over 8. And I get, oh. So this point right here is it. The other way you could have done it is seeing that 32 is going to be divided into 8 equal pieces. So I know this is going to be 4, 8, 12, 16, 20, 24, 28, and finally the end here is at 32. All right. Let's keep moving forward. Example number 1. So we're going to do 3 examples, and then the rest you're doing on your own. So example number 1, the best thing I like to do is draw my picture first. And again, I know R is on my left because it's got the smaller x coordinate. So I'm going to draw this segment R. S is at 6, -3. And R is at -3, 3. Okay? And I'm dividing my segment to the ratio of 2 to 1. So it's going to be 2 over 2 plus 1, which is 2 to 3. So I'm going to divide this into 3 equal pieces. And this is where my point Q is going to be, because this is 2 parts to 1 part. All right, so now I got to actually do the math, which is always fun. So I'm going to do my change in Y, which is my slope. I'm going to change in X. So my change in Y is -3 minus 3. Change in X is 6 plus 3. So I get -6 over 9. And I'll multiply that by my change ratio, which is 2/3, right? And so then I end up at -4, 6. So now I'm going to take my first coordinate, R, which is at -3, 3. And be careful, I'm subtracting 4 from the Y, and I'm adding 6 to the X. So my point Q is at 3, -1. I'm moving kind of quickly because I only have 15 minutes to get this done. Next, I'm going to find the coordinates of P. So once again, I got the point A. A is the smaller one because it's at -8, -2. And B is further down the line because it's at 6, 19. I want to find point P. So it cuts in the ratio of 2/5. 2/5 is already a part to whole ratio. So I can just divide this 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 2 of them is right here. So that's where P is going to be. Now to figure it out, I'm going to do my same steps. 19 plus 2 over 6 plus 8. And I'm going to pause this and just show you the answers from right now. This is kind of quick, but this is the answer. You can pause the video and see where the numbers come from here. For this one, I've worked out each of the steps to show you that point P is at 1.20, and it's nice because I can check that on the graph. You got to be careful for this one because they gave you the letter C first, and C comes before D in the alphabet, but this is a tricky one. 6 is further down the line than -3, so when you drew the picture, D should have come first on your line. And then the practice problems, the answers are here, but you need to go ahead and show the work.